All right, welcome back to statistics. We are going to be talking about section 7.3, essential limit theorem, and this section's pretty much we've covered some of the early stuff, so we just have a bunch of problems to go through, and that's what we're going to do. I'll try to explain and reinforce some of the essential limit theorem stuff that we learned earlier, but yeah, that's going to be through the problems here. Okay, so we go ahead and share the screen. And here we have some problems, all right? So problem number 3, this is where we left off. A sample size of 32 will be drawn from a population with a mean of 42 and a standard deviation of 10. So let's go through. And these are almost like this problem. I wish it had a story with it, and then I would really like this problem. So first off, is it appropriate to use the essential limit theorem? Okay, is it appropriate to use a normal distribution for x bar? This is not a yes or no question. Okay, so yes, because, right, n is greater than 30. And we know from CLT, right, CLT essential limit theorem, okay, CLT, it's appropriate, okay, because it's bigger than 30. So at this point, it's like, well, is it appropriate to use the normal distribution? Yes. What is the probability that x bar will be between 43 and 44? Okay. So what do we have here? We have x bar is approximately normal. What's our average? Right, remember, the average is the average for x bar is the same as the average for the underlying population, right? The average of the averages is the average. Okay, so mean 42, right? And then we have a standard error, right? The standard deviation for x bar, that's called standard error. Okay, I'm not going to quiz you on that, by the way. Standard deviation is 10, sample size is 32. Okay, so we have a standard deviation of 10 divided by the square root of 32. That's my sample size. Okay, so we have that. Okay, now we can calculate this out, right? And that's fine. I would recommend at least 4 decimal places, but maybe 3 will be okay. But the calculator will actually do this part for us. Okay. So if you wanted to write in 1.77 or 1.768, that would be okay here. Okay, but let me show you the probability between 43 and 44, right? So we want probability 43 x bar 44. What's that going to look like? All right, so we're going to go to second function distributions. Okay, we're going to go to normal CDF. Okay, what's our low number? Our low number is 43, right? Because really what we're doing is norm CDF. We have a 43. Our high number is 44. What's our average? Right, the average was 42. And our standard deviation is going to be 10 over the square root of 32. And you can enter that, and it'll say that's fine. So 43, 44, 42, min, max, average. And then what we're going to have here is 10 divided by the square root of 32. All right. So go ahead and do that. 42, this was like almost 2-ish. So it's kind of between like, it's somewhere between like a half and 1 standard deviation away. So that seems about right. We ended up with 0.15685. 0.15685. This is going to round, so we have 0.1569. Okay, 15.69%. All right. So we'll double check that. 15.68 So that's going to ground up to a 9. So point, okay, so 0.1569. 0.1569. All right. So yes, it is appropriate. Probability is, what's the 36th percentile of X bar? By the way, if you're taking a quiz for me, I mean, I might include this as an option, because it is not appropriate to use a normal distribution. I won't do that to you. Okay, if I have to go through and give you a whole problem, go through ask you to do all of this, like that's kind of like a bluff question, and I don't like to do that to you. So I might do like a multiple choice section, where you have to yes or no, and I would give you the thing, but then there would be like a bunch of there would be a bunch of scenarios, and you'd have to pick when is it appropriate and when isn't it appropriate. But I don't like to put a whole question like this and then say, well, I got you, it wasn't appropriate. Like, now that's not fun. Okay, so 36 percentile. So here we're given a percentages, we have to go back to a value. Okay, so that's going to be norm inverse 0.36 for our percentile. Okay, again, what was our average? Our average was 42, and our standard deviation was 10 over the square root of 32. Okay, so what we're going to do is we're going to say second function distributions, inverse norm. Okay, and we're going to take 0.36, comma, 42, comma, and then 10 over square root of 32. 32. All right, and that's how we're going to calculate that. Well, that's how we're going to make the calculator calculate that. And we ended up with 41.366. So it's 41.37. Okay, this is still an X value. Usually X values go to 2 decimal places. Okay. They say otherwise. They didn't say. So our rule of thumb, right, 41.37. All right. And we should be able to go with that. Boom, boom, fingers are crossed. Very good. All right. Next value. Okay, now this is a question that I have. I would feel much nicer answering this question. Okay. So mean serum cholesterol level for U.S. adults was 202. Standard deviation, this seems a little bad. Standard deviation is 41. Random sample of 110 units is chosen. 110 adults is chosen. Okay. So I'm going to ask you the same question. Like, is it appropriate to use this? We don't know the underlying distribution. So, but is our sample size bigger than 30? Yes, right? We have 110 folks here, 110 adults, that's bigger than 30, we're okay. Okay, so CLT applies. Okay, and what do they want to know? They want to know what's the probability the mean cholesterol is greater than 210. Okay, so understand what we're doing here. The average of everybody is 202. So we're taking this group and we're saying, what's the probability that this group is greater than 210? Okay, so this group has actually got higher than, my doctor would yell at me for this cholesterol. So our values are higher than what this is. Okay, standard deviation was 41, so we have our average was 202. Our standard deviation was 41, and our sample size was 110 adults. Okay. So what are we going to do with this? We're going to say norm inverse, or no, we're not. We're going to say norm CDF. Okay, our low number is 210. Right, our high number picks something off the charts. Okay, we'll come back to it. Our average was 202, and our standard deviation was 410 divided by square root of 110. Now, what's the square root of 100? That's 10. What would be 41 divided by 10? That would be like 4. Okay, I'm just trying to get like a basic idea of like how big approximately is a standard deviation, so I know what steps I'm going to be taking. Okay, So this is already 2 standard deviations up, right? 202 plus 4 plus 4 again. So 202 plus 8 is 210. So this is already 2 standard deviations away from the mean. So we need to go for what's a big number in comparison to 202. If we step, every step away from 202 is 4 units large. Okay. So in order to get to 210, that's two steps. Okay. If we wanted to go on more, right, that would be 214. Okay. So pick a big number in comparison to that. You want to go with 500? That's fine. You want to go with 1,000? That's fine. But you can do this 1EE99, but it's unnecessary. All you need is far enough away from this average by taking these, and this is how far away you're allowed to move any one step. So as long as I'm far enough away from this value, I'm going to get a good upper number. Okay. So just be careful with that. Again, you can just type in 1EE99. I just don't like doing it. So second function, distribution. Norm CDF. What's my low number? My low number is 210. My high number, I said that was going to be 500. Okay. If you said 1,000, it's fine. It'll work. Okay. 202 for my mean. And my standard deviation is 41 divided by square root of 110. All right. Two parentheses, one for the square root, one for the norm CDF. All right. And we know, like, it's above 2 standard deviations. So if I would have expected at 95%, this would have been 2.5%. Empirical roll. Okay. But we have 0.02035, which is going to say 0.0204. All right. That's fine. Okay. By the way, 0.0204. I would be delighted if you could follow along with me with all this empirical roll stuff and trying to estimate it. But if you're like, well, look, dude, I got the calculator numbers going pretty well, and that makes sense to me, I'm happy. You're going to do fine. Okay. I'm not going to ask you to estimate like this. All right. That's a little bit, that comes a little bit later. It comes with some practice. Okay. But this is not a skill you're required to have to pass Stats 101. Okay. So we have to go for norm CDF, right? We have our low number, 190. We have our high number, 200. We have our mean, 41. Oh, no, it's not 41, it's 202. 202. And we have our standard deviation. This was 41 over the square root of 110. Okay. So again, this was about 4. If I subtract off, what, 12, that's going to be 190. So we're going to about 3 standard deviations down. I mean, roughly. Okay, so we're going to go from about 3 standard deviations down to 200. That's going to be too close. So almost the average. So it's not going to be 50%, but it's going to be a little under. So if I get like somewhere between 0.4 and 0.5, that's probably about right. So let's go ahead and do this. Okay. So we're going to go in and say second function, standard deviation. All right, we have our low number, 190. We have our upper number, which is 200. We have our mean, which is 202, right? And our standard deviation of 41 over square root of 110. 2 parentheses, one for the square root, one for the normal CDF. Put that in there. Okay, a bit further. Okay, I know why I was a bit further off is because this was half a standard deviation down, so maybe not quite this close. Okay, so 0.30338. 0.30338. So 0.3034. Right. So this was 0.3034. Right. would it be unusual for a group to have less than 198? So would it be unusual? What's the probability that X bar would be less than 198? Okay, so we're going to do norm CDF. Pick a small number. Okay, 0 is a small number for this group. 198. Okay, average is 202. Standard deviation, about 4-ish. So 41 over the square root of 110. Okay, so 202. All right. So let's see here. I had a momentary brain thing going on here when I was thinking about, like, what is the average cholesterol? What should it be? The average, actually, no, I think my doctor wouldn't be so mad at me for having a 200. I think your healthy value is 200. So if I had 202, I think they'd be okay. 198. All right. And then what was our standard, or our mean? 202. Our standard deviation was 41 divided by the square root of 110. 2 parentheses. And we should be okay. So this was 0.1531. Okay, so 0.1531. So not less than 5%, right? That's 15%. So not that unusual. It would not be unusual for a sample mean to be less than that, since the probability of finding it, 15.13%. So 0.15 was the last 2 digits. No idea, 31. Okay, check our answers. Okay, and there we go. So that would be a fair quiz. That would be a fair question on a quiz, right? I would like that one. Straightforward, nice. Okay, this is effectively the same problem. I think we can skip this one. Let's skip that one. All right. So there's going to be a similar problem, but let's just reinforce it, okay? All right, high rent district. The mean monthly rent for a 1-bedroom apartment without a doorman in Manhattan, monthly rent, my goodness, $2,693. Okay, assume the standard deviation is $500. Okay, a real estate firm samples 115 apartments. Okay, 1-bedroom apartment, 1 bedroom, almost $2,700. Oh, goodness. All right. So real estate firm looks at this, 115 apartments, 1 bedroom, no doorman. Here's our values. Use your calculator. What is the probability that the sample mean rent is greater than this? Okay, 4 decimal places. These are not the same numbers. All right, so can we use central limit theorem? Does CLT apply? Well, since n is greater than 30, right? Specifically, n is 115. Yes, it does apply. We're allowed to do this. Okay, our mean is the same mean as the average, right? So we're going to say 2693. 2693. And our standard deviation, right? Because they gave us that was 517 rather, 517. So our standard deviation for X bar, standard error, right? 517 divided by the square root. What's my sample size here? Sample size was 115. I have it right here. Okay. All right. We don't really need to calculate this. You can if you'd like. Okay. Some people prefer to do it that way. It's fine. There we go. So 48.21. All right. Let's answer some questions. Down for a moment. All right. What is the probability that the mean rent is greater than 2763? Around 4 decimal places. So what we want right, is probability that x bar is greater than 2763. That's the value they gave us, 2763. All right, so we're going to put in norm CDF. Here's our low number, 2763. Okay, here's my average, 2700. And we get to count up by 50s. Oh, 300, 400. And let's just put in 10,000. Okay. Our average, this was 2693. And our standard deviation, 517 divided by the square root of 115. All right. So there we go. Yeah. And again, the trick is just getting far enough away by standard deviation steps. Okay. So you may have been able to pick 5,000 and get off of that just fine. Pick 10,000. You could pick 20,000. You know, this will be a 10 when 1 EE 99 would probably be fewer keystrokes. Okay, so that's baiting me. But second function, distributions, CDF, enter. Okay, our low number was 2763, comma. We've got 1,000, 10,000 rather. 10, 1, 2, 3. Okay, our mean 2693, and our standard deviation 517 divided by the square root of 115. And parentheses for the square root, and parentheses for the normal distribution. Boom. Okay. 0.07. What do we have here? 0.7325. 325. For 4 decimal places is going to be 0.733. Okay. So 0.0733. 0.0733. Okay. 5 parts. I should have picked a different problem. What is the probability that the sample mean rent is between these two numbers? Okay, round to at least 4 decimal places. Okay, so it's not going to be so bad. So they want to know what's the probability that we are between. What we're going to do is that so I could see it all. So we have 2562 somewhere. My grouping here, and we're going to have 2662. Okay. So what's my average here? 48, right? And that seems like about 50 lower. It seems maybe it's 100 lower. Yeah, it is. It's between like -1, -2 standard deviations. So what is that? 16%, 14%, something like that. So again, empirical world. All right. So our low number, 2562. Our high number, 2662. Our average, 2693. Our standard deviation, 517 over the square root of 115. All right. So let's go ahead and check this out. So that's going to be inverse distribution. Okay, 2562, comma, 2662, comma, 2693, comma, 517 divided by the square roots of 115. Right? 1 parentheses for the square root, 1 parentheses for the CDF. 0.256, 2.25681. So our answer 0.2568. All right, so way off of my estimate. So that was clearly a terrible choice. 2568. 0.2568. 2568. Okay, what's the 65th percentile? Okay, now again, remember this is for a group. This is for an average of these apartments. Okay, so we're going to say norm inverse, right? What's the probability? It's 0.65. Okay, what was my average? It's 2693. And my standard deviation, 517 over the square root of 115. All right, we're going to plug this in the calculator and see what we get. Okay, so the 65th percentile of apartment rents here, or this, it's a group of apartment rents. Okay, distributions here, norm inverse. All right, so probability 0.65. Okay, our mean 2693, comma, okay, standard deviation 517 divided by the square roots. There we go, of 115 and equals. Okay, so we have 65th percentile. All right, 2775. This 6 is going to turn into 0.58. Okay, that's your 65th percentile for rent on a 1-bedroom apartment in Manhattan. You can tell I'm not over the sticker shock of those prices. That's quite a bit more than my mortgage. All right, let's see here. This was 2711. 271. Well, I think I'm mad. 2711 dot. You know, that's where you say the and. So if I was going to pronounce this number in English, we would say 2,711 and 58 and 58 cents. The and is where the decimal place goes. So people who say 1,300 are like, that bugs me. Doesn't bug me to say anything about it, but it should be 1,300, and that's where the decimal place is. Okay, would it be unusual if we had a mean greater, sample mean greater than 2,751? So X bar, we have to figure out what is the probability, right, that it is bigger than 2,751. See, I just did it, 2,751. All right, so we're going back to norm CDF, right? We have a, we have a low number because we want more than this. So 2,751. And then we have to figure out like what's a good big number relative to what was my average. Average was 2693. All right, and my standard deviation was 517 over the square root of 115. Let's type in the 1 EE99 this time. Okay, just to put that in there for a change. Okay, so second function distributions, CDF, okay, 2,751, big number. Remember, it's not EE like alpha EE, it's second function, comma, because it's this little EE right here. All right, 99, okay, 2693 and 517 over the square roots of 115. Okay, we end up with 11447, so 1148. All right. So it is not, right? Would it be unusual? No, right? That's almost 12, well, it's about halfway through 11%, so 11.5%-ish, okay, 11.48%. Okay, 0.1148. That is bigger than 5%. do you think it would be unusual for a rent greater than 57? This is an individual. Okay, so notice they do this. Assume that the variable is normally distributed. If they didn't tell us that, we couldn't do the problem because we don't know what distribution this is. And you can see, like, look, we're going to look at this thing. We're going to say distributions. This isn't even all of them, right? We have normal stuff. We have a t distribution. We're going to learn that in chapter 8. We have chi-square. We have an f. We have binomial. We have Poisson and geometric. It doesn't even talk about Gaussian distribution or beta distribution. I don't think there's an alpha, but there's lots and lots of distribution. This calculator doesn't even have all of them. Okay, so they have to tell us, hey, it's normal. Okay, so what we're going to do, this is a 7.3 problem, or 7.2 problem rather. So they want to know what's the probability that x is greater than 2751. Okay, so we're going to do norm CDF, right? We want 2751. I'll do the same thing. I'll say I need a big number, so we'll just do that. What was my average? It was still 2693, but my standard deviation now is 517. We don't have to divide because we're talking about a single person's apartment. Okay, not a group of 115. Okay, so here we go. Second function, distribution, norm CDF. We're going to do 2751. Okay, comma. We need a big number, so 1 99. Okay, 2693, and then finally 517. Okay, I'm going to say it would not be, because that's not even out of one standard deviation, right? Well, one standard deviation up, right? That's 27, 27, and 5 is going to be, this should be 3,200. Okay, so I don't think it's going to be very, uncommon at all. What do you know? 4553. Okay, do I have a rounding thing? 4553. No, we're good. So there's our probability that we are spending more than $2,751 per month on a single bedroom apartment. Okay, so no, it's not unusual. 0 point, okay, 4553. 4553. All right, my fingers are crossed here. Let's see what we got. All right, we're okay. All right, that was a long one. All right. Perfect. They have the plane one too. They have the elevator one. All right. Let's see. I'm just trying to decide which of these I like more. I actually like both of these problems. Okay. So, well, number 4, like that was a pretty standard problem. This one is not. Okay, this one's a little tricky. I like this one. Of course, I was going to say that, right? All right. Engineers are designing a large elevator that will accommodate 42 people. Okay. The maximum weight the elevator can safely hold. So we're going to have max weight. 8,148 pounds. Okay. So the weights of U.S. adult men is 118 pounds. So we'll say, is it this symbol for male and this symbol for female? I think it is. Okay. All right. So we have 188, and the standard deviation is 63. All right. And for adult U.S. women, we have 158 and a standard deviation of 72. So mu of that is going to be 158. And standard deviation, oops, that's sigma. It's a weird thing to draw, right? So sigma for women is going to be 72. So female, male. Okay. All right. So first thing we have to do, okay, and I will, if I'm going to do a question like this on a quiz, I'm going to pretty much follow the exact same format that they're doing right here. Okay, these problems are a little on the difficult side. I see no reason to deviate from this and to give you the walkthrough that they give us. If 48 people are on the elevator and their total weight happens to be 8,148 pounds, what is their average weight? So what we're going to do is X bar is equal to 8,148 divided by how many people are on the elevator, 42, equals, so we're going to say 8,148 divided by 42. One, of course, it came out to be integer. It's not like this came out of a textbook or anything. So our average weight is 194. Okay. Okay, you have a random sample of 42 adult men are riding the elevator. What is the probability that the maximum safe weight will be exceeded? It's a good question. Okay, so we want to know what is the probability that the average of these 42 guys is greater than 194. Okay, so how are we going to set this up? We need norm CDF, right? We need the low number. Okay, we'll say the high number. Okay, let's see. Scariest show on TV, my 600-pound life. Okay, our average is average of the averages is the average. So what is our average here? Was it 178 or 188? Can't remember already. 188. Now I know how you guys feel, right? All right, and we need a standard deviation. So our standard deviation is going to be 63, but it's a group. So the standard deviation is 63 over the square root of n, 42. All right. So let's figure out the probability that we exceeded this weight. Oops, I don't want that. Calculate is what I want. So we're going to take second function, norm, CDF, okay, 194 up to 2,000. Have an average of 188 and a standard deviation of 63 over square root of 42. All right, equals. All right, this seems a little high. So we have, yeah, it does, but it seems a bit high. So that's 0.26854, 0.26854, 26854. This doesn't really count, so it's just 0.2685. I would not want to get on that. If I lived in a fraternity, I would not want to get on that elevator. Okay. So if there was some kind of conference with all guys in it, would not want to get on the elevator. Okay. What about the women? So this was for the men. Then we're going to say, well, if all the women get on it, if 42 women get on this elevator, so we have this elevator in a sorority, what's their probability? 0.2685. 0.2685. 0. All right. Okay, 42 women are riding it. So we have norm CDF. Right, we want to know about getting bigger than 194. We'll still use the same big number. Okay. But now we have a 158 average. right? And a standard deviation is going to be 72 over the square root of 42. All right, so that's what we're going to type into the calculator. All right. So we have second function distribution, CDF, enter, 194, 2000, right? That's, we were looking for the minimum, right? This is the chance it's going to go over. So we need 158, and then comma, and then square roots. Oh no, not square root yet. We just want 72 divided by the square root. There we go, of 42. All right. All right, so this is 5.96969. This is a good question. Okay, 5.969. And then you have this E -4 here. All right, a lot of students do not know what this means, and I don't blame them. What this means is we're going to move the decimal place 4 units, okay, to the left because it's negative. Okay, so we're going to say this is 5.969. We got to move the decimal 4 places. So 1, 2, what do we put here? It's a 0. 3, 4. And there's a leading 0 with the decimal place. So we went from 1, 2, 3, 4. Okay, so we stop here. This is how many zeros we have to add. Okay, so when I round this, this is 0.000. This is going to turn this into a 6. Okay. So that would be how we're going to do this. Okay. So when you see this E here, remember that's telling you move the decimal place. All right. If you write down, oh, my answer is 5.969, and you just like, well, I don't understand it, so I'm not going to write it. Like this is going to be wrong in a couple of ways. Like first off, you came up with a probability that is bigger than 1. That is automatically like points off. Okay, tell me a probability is bigger than 1. Like that doesn't work. Okay, and then secondly, it's like that we're not getting the right answer. I know you kind of got close to it, but you got to put the thing in. So it's automatically like a more punishable offense than just getting the answer wrong because you told me it was bigger than 1. So there's our probability. Okay, just came up with it. I guess you could come up with like a book with a murder plot is like these 42 women got together and decided to see if they can or kill their boyfriends because their probability of riding in an elevator is very low to be overloaded, but their probability is like a quarter of the time. Still not 100%, but you know, yeah, it's a fun way to put a math problem into a murder mystery. Okay, this was 0.0006. All right. So if you're making this elevator for a fraternity, you probably got to rethink that decision. If you're making it for a fraternity or for a sorority, the chance of overloading it is extremely small. So we're probably okay. All right. By the way, that's how engineering is done. It's like they don't use 5%; they use less than that. But you can't do it to 100%. Nothing is 100%. So just be aware that everything that we do, cars, highways, all of it, it's not 100%. Okay, there's always some risk of, well, didn't work. All right, so fortunately that's small. All right, I think that's going to do it for our 7.3 versions. Okay, if we need to, if I'm going to put one of these on your quiz, very likely, there'll be another quiz review. I will definitely do, not this one, but the quiz review will probably have this one in it. All right. So good luck, and I will see you in the next video, which might be a while. All right. Take care.